Okay, so 1.6a is absolute value. We're going to talk about absolute value for 1.6a and 1.6b. Today is equations. Monday is inequalities. What's the difference? An equal sign versus the symbols we've been dealing with. Greater than, less than, all of those, okay? So absolute value equations. The first thing you have to understand is just what absolute value is. I think if you can wrap your mind around what absolute value is, it makes the solving of the problems make a lot more sense, okay? Here it is. Absolute value is a real number that is a distance from zero on some number line. So if I have a number line, okay, and this is 0, and I want to know how far away is this from 0, it's not -3 from 0, right? It's 3 units away, 3 units to the left. Yes, it is a -3 that we land at, but the distance is always positive. We went 3 units away. Same thing if we went this way, and this was a 3. We went 3 units away from 0. So that's why absolute value is always positive, because a distance is positive, okay? With that then, they give you this information. That's terribly ugly, I'm sorry. It says if the absolute value of x is equal to a, then I can say that this, whatever's inside the absolute value bars, either has to equal the positive version of it or the negative version of it, right? If I put a -3 inside of there, the absolute value of -3 is a +3. The absolute value of a +3 is a +3, okay? So maybe write this down. Once we isolate absolute value, let's just say once you isolate absolute value, you are going to write two equations today. Sorry, 2 equations. Okay, and it's essentially this idea. If I know the absolute value of something equals a, then my x could be a or my x could be -a, and it will still equal a +a when I plug it into the absolute value. Okay, so we're gonna go through a few equations. The first is if the variable is on one side of the equation, okay? These ones are simpler than the others that we're gonna do in a little bit. But here's how it works. And I am gonna baby step you through this first one, which is gonna make some of you feel like this is ridiculous. Can she please just speak to me like a normal person? But I want you to wrap your brain around why I'm able to do what I'm going to do right now. And then once we do that, then we'll go through the rest of them at a normal pace. But I need you to understand why we're doing what we're doing, okay? Here it is. If I say the absolute value of this is 5, that means that right there, that's in the box, could be a 5, or it could be a -5, right? Basically, I'm saying if I ended up with the absolute value of -5, it's still going to equal 5, okay? So what we do with these absolute value problems, and maybe you remember this from Algebra 1 because you did it, but I feel like they always get done wrong. What you're doing here is you're taking the absolute value bars away. Oops, that's not what I want. This is what I want. You're taking the bars away and you're writing 2 equations. You're writing 2x minus 1, so what's inside, can equal 5. So you write it exactly how you see it without the bars. Or your other equation is 2x minus 1, so what's inside the bars can equal the -5, right? So one is the positive, one is the negative. They will both work when we plug them back into this equation, okay? Okay, so let's do that. We would add 1 here, and we get 2x equals 6. Then divide by 2, we get x equals 3. Okay? The second equation, add 1, and we get 2x equals -4, and then divide by 2, and we get x equals -2. Okay? Now, plug those back in. If I plug a 3 in right here, I get 2 times 3 is 6, 6 minus 1 is 5, and the absolute value of 5 is 5. True statement, right? Plug in the negative 2. 2 times negative 2 is negative 4. Negative 4 minus 1 is a negative 5. The absolute value of negative 5 is 5. So that's why both of those answers work. Does that make sense to you? Okay. Moving on. If we graph this, because it's an equation, you have a negative 2, negative 1, 0, 1, 2, 3. Okay? When it's an equation, your answer is a point. So my answer, my graph here, is a point at negative 2 and a point at 3. So when they ask you to graph an equation, plot a point. No arrows, no shading, a point. Okay? Just a point. Because x has to be that number or the other number. All right? Okay, let's look at letter B here. Letter B steps it up just a little bit because, and I wrote it up here, once you isolate the absolute value, that's when you can write the two equations. Is my absolute value isolated here? No, absolute value is not by itself, right? We need to get it by itself. So how do I do that? Add 1. Ooh. So add 1, we get 3 times the absolute value of x plus 2 equals 9. Then what? Divide by 3. Divide by 3 on both of those, and we get the absolute value of x plus 2 equals 3. Okay? Now it's isolated, right? So just make sure, maybe you write a big isolate next to the problem. You have to get absolute value by itself. Once you do, then what do? Write two equations. Okay, now you can set one equal to the positive and one equal to the negative. So this is going to be x plus 2 equals 3 and x plus 2 equals negative 3. Okay, from there we solve. Take away 2, you get x equals 1. And then over here, take away 2, and you get x equals negative 5. Okay, if I graph that, I have a number at negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1. I don't need all the hash marks in there, but if it seems like spacing is an issue, you should put them in. In these ones, it's not. So a point at negative 5, a point at 1, and you're done. Questions on that? All right, you try C. Set that one up, see what you get. Feel free to chat with your neighbor if you're sick. And if you finish that one, you're welcome to take a look at D too. I remembered. What did you get for C? Negative 14 and negative 4. Okay, here it is. You have to isolate first. So the first step in isolating is get rid of the 5. Okay, that's gone. Negative 2, absolute value of x plus 9 equals negative 5 minus 5 is a negative 10. Then divide by a negative 2. Get that absolute value by itself. That is a 1. So you're left with the absolute value of x plus 9 equals 5. What do you do next? Two equations, right? Once you've isolated, x plus 9 equals 5 and x plus 9 equals negative 5, the opposite, okay? So solve that, take away 9. 5 minus 9, you get x equals negative 4. Take away 9. God bless you. You get x equals, God bless you, negative 14. Okay, and I'm not going to graph that. I feel like we got the graph part of it. It's pretty straightforward, right? But that should be your answer. Questions on that? Okay, somebody impress me. What did you get for D?
I have an answer. I don't want to say that. It's probably
Casey.
wrong. It's probably
Negative 6.5 positive 1.
That's tempting. What'd you get, Megan?
There's no solution.
There's no solution. Trick question. It's meant to throw you off a little bit, right? Absolute value of something can't equal a negative. Now be careful because the one before it looks like it did, right? Why was this one okay to do?
Because it had numbers of values.
Because by the time you isolated, it wasn't equal to a negative, right? So once isolated, if it equals a negative, it is impossible. Therefore, there is no solution. Don't you kind of love it when things like that happen, where it's like, oh, gotcha. I kind of love it.
Negative, if there's no solution.
If what the absolute value of something equals is a negative, there is no solution.
it's not possible. That's why.
Yeah, not possible to have a negative answer there. Okay, here's where they get a little fancier again. Now there's going to be variables on both sides of your equations. And when you get variables on both sides, you have to check for what are called extraneous solutions. Okay, extraneous solutions. Basically, an extraneous solution is just an answer that is not a real solution. Okay? It's an answer that's not a real solution. Yes?
What's the point if it's not a real solution?
Well, here's the thing. Because of the absolute value, it kind of messes with our numbers a little bit, right? So you're going to solve it, and you're going to get two answers. But if you were to plug both of those answers back in, chances are one of them doesn't actually work in the situation because of the absolute value. So I'll show you right now what I'm talking about with this. So you still have to isolate. Is my absolute value isolated in A? Yes, it is by itself on the left side of my equation, okay? So once you isolate, what are you supposed to do? Two equations. Okay, now here's the two equations. This is where everybody messes up. Don't be that person. Be the one that does it right. You take 3x plus 2 and set it equal to 4x plus 5. Okay, that's the first one. That's the easy one. That's the one everyone does right. Here's the one everyone does wrong. If we set it equal to the opposite, right? Right now it's the positive. We set it equal to the negative. It's essentially this. 3x plus 2 equals the opposite of all of that, right? Which means every sign gets changed. So if it's negative, it becomes positive. If it's positive, it becomes negative, right? So let's distribute this.
Wait, does that include the sign that's not included parentheses?
The negative right here?
Yeah.
I'm saying that negative is changing all of your signs. So what this started as 4x plus 5 is going to become negative 4x minus 5, right? So this is 3x plus 2 equals negative 4x, that's a negative, minus 5. So you're solving this and this. Does that make sense? Make the entire right side the opposite of what it is. Okay, so simplify. I'm going to take those boxes away. Take away a 3x from both sides on that left one, and then we get an x. Then I'm going to move this 5 over to the other side. 2 minus 5 is a negative 3. Okay. Move over to the right side. I would add 4x. Ew. It's being real fickle today. So if I add that, that's 7x. I'm going to take away the 2. Bring down your equal sign. So negative 5 minus 2 is a negative 7. And then divide by 7. So x is negative 1. Okay? But you have to check for extraneous solutions when your variables are on both sides. All you got to do, God bless you, is plug it in. So if I plug it in, let's plug in a -3. So it would be the absolute value of 3 times -3 plus 2 equals 4 times -3 plus 5. Okay, simplify that. -9 plus 2 is the absolute value of -7. -12 plus 5 is -7. Is that true?
Yes. Yes, because.
No, the absolute value of -7 is +7, right? 7 does not equal -7.
Oh, wait. Oh, yeah.
Therefore, we say this
The extravagant.
is extraneous. Okay, so I need to see the answer, but I need to see that you knew it was extraneous. So leave me the x equals -3, but then write extraneous by it. Okay? Now check the other one. And you always plug it into the original, not the new one that you came up with. Plug it back into the original. So the absolute value of 3 times -1 plus 2 equals 4 times -1 plus 5. Okay, simplify that. -3 plus 2 is the absolute value of -1. -4 plus 5 is 1. Is that true?
Yes.
Yes, 1 equals 1. That checks out. So this is a correct answer. This, -3, is extraneous. Make sure I can see the word extraneous by that answer. Okay? Okay, this one, I'm going to change it because it is much prettier the way I'm going to give you right now. Just make the problem, write this in black so you can't even tell that you altered the problem. We're going to make that 7x plus 14 to start the problem. Actually, you know what? It doesn't matter. It doesn't matter. Whatever.
Yeah, we
Well,
need to cross our midline.
this is the last one. I mean, cross your midline. Go for it. But this is our last thing.
Miles, bro.
Okay. Last thing. And then we're done. What do we do?
Make 2 equations.
2 equations. The first one, 5x minus 2 equals 7x plus 14. Okay, that's your first one. The second one, the trickier one, is 5x minus 2 equals what? -7x minus 14. Change the sign of everything. So if it was 7x minus 14 to start, you would say -7x plus 14, right? Change the sign of everything. So -7x minus 14. And then we solve. So take away the 5x. And you get 2x. And then I'm going to move this 14 over to the other side. Take away 14. You get a -16. That goes away. That goes away. Okay, divide by 2. So x is -8. Where'd I get what? Okay. Then move over to the next one. I would add 7x to both sides. So I get 12x here, and then add the 2 to the right side. This is gone, this is gone. 12x equals a -12. And then divide by 12. So x is -1.
Like, which one was wrong?
Which one's extraneous? You'll get a point off. Because the extraneous is a point and the answers are a point.
Why do you add the 7x on that side but not on that side?
Because it would be negative.
Because it was a negative on this side, right? When we change the sign of everything, it's a negative. So I got to add it to get rid of it. Over here, it was a positive, right? So then I just chose to move the 5 over. You can move the 7 over. It will still come out to the same answer. You'll just work with the more negatives if you do it that way. But that's fine.
Because I was doing it that way and I just got stuck.
On which one? The first one or the second?
Yeah, the first one.
So if you're at 5x minus 2 equals 7x plus 14 and you decide to move the 7x, No, you want to move 7x. So if you subtract that, that's a negative 2x. So that means we want to get the 2 out of here. So that would be 16 divided by negative 2, and you still get a negative 8. Good? Yes?
Yes.
Okay. Okay. So now we just have to check for our extraneous. Plug them in. So, and you always plug into the original, right? Use the original. So the absolute value of 5 times negative 8 minus 2 equals 7 times negative 8 plus 14. Plug that in. Negative 40 minus 2 is a negative 42. Take the absolute value. Negative 56 plus 14 is a negative 42. Does that work?
No.
No, this is extraneous. Okay. Then try the negative 1. 5 times negative 1 minus 2. Take the absolute value of that. 7 times negative 1 plus 14. This is negative 5 minus 2 is the absolute value of negative 7. 7 times negative 1 plus 14 is 7. That one checks out. So your answer is x equals negative 1, and the x equals negative 8 is extraneous. Good?
No.
What are we gonna do now?
We're done. What do you want to do?
Switch school?
Let's play a game.
I mean, you have 3 minutes.
Go here.
Right? 105?
Oh, you need your character.
Yeah, 105.
Oh, you didn't do it?
Any questions?
No, ma'am.